Hey guys, how's it going? So today we have a binary search problem, leaf similar trees. So consider all the leaves of a binary tree from left to right order. The values of those leaves form a leaf se value sequence. Sorry. Um, so basically what this problem's wanting us to do is we're just taking all the leaf values, which are basically going to be the very bottom values in a binary tree. So like right here, they have no children. So like the every single one will have a parent node. Um, but basically if the parent node doesn't have a child node, it's considered a leaf of that binary tree. And so, yeah, it's not too hard of a problem. We're just gonna break it down using a separate method. But here, let's go over here. So basically, what we're gonna use is a depth first search algorithm, which you can use a breadth first or a depth first. Depth first is definitely easier in this case. Just because the fact, let me see here. Let's see what I can draw with. All right. So basically, what we're gonna do is we're gonna kind of sort of cut off part of our binary tree, right? So what we're gonna do is this. Well, basically we're gonna take this. This is not wanting to work with me right now. There we go. Yeah, there we go. Yeah, so basically what we're doing is we're taking this right side or left side of our binary tree and we're going to search it first, and we're going to search the whole left side. And then after that, we'll search this right side, and I'll show you kind of how we break that down. But that's sort of how depth first, that's like a very basic, dumbed down version of how it works. But basically, you're picking sides of the binary tree, and you're sort of breaking it down before you go to the other side. And you do that within every subtree, right? So let's go back over here. Okay. So to start out, we need to create two lists in order to hold the values of the leaves for both of our binary trees. So we'll start with root one. We'll just call this one, let's see, we'll just call it tree one leaves equals new array list, right? Okay, I'm gonna make another one. Integer tree two leaf, new array list, right? And then what we're going to do is we're going to go ahead and we're going to sort of like call our methods, if that makes sense, even though we haven't technically made it. Um, and so we'll pass in, let's go and yeah, we'll go and pass in our list. So we'll go and pass in tree one leaf, and then we'll go ahead and pass in root one. And then we'll do the same thing for tree two. We'll call tree two leaf, and then root two, right? All right, now let's create our method. So private, and then we're going to make it a void method type because we're not actually going to return anything since this is going to be a recursive method. So private void, and then we're going to call it DFS for depth first search algorithm. And then what we'll do is we'll then define our parameters. And then we'll just call this one list. And then we'll call this one, call it tree node root, right? Yeah. Okay. And then so what we'll go ahead and say is if our root value equals null, we're just gonna go ahead and return because it'll basically just break the method. And the reason that we do that is because if let's say we're right here at this 8, if we were to recursively call to the next if we were to recursively call to like our next node using root dot right or root dot left, basically both those values should be null since that's a child or that's a leaf within the binary tree. So therefore, there shouldn't be any value below it, so it should just be null, right? And then do if our root dot right equals null, and our root dot left equals null, then we're going to add that to our list, right? Because then that means that we have no value below it we have no value below it that should be a leaf or that it can be a parent of, right? So we'll just do list, we'll do list dot add, and then we're just going to add our root dot value, which should be root, yeah, root dot val. And then we're just going to recursively call these methods using our list and our root dot right, and then our root dot left. So that way we go both, we search our binary tree both from the left and right, right? Okay. And then we're just going to return if our tree one leaf dot equals tree two leaf. Okay, and then we'll run it. Okay, and we'll submit it. Okay, perfect. So, for really, really good space-time complexity, um, if you break it down, it becomes pretty simple. If you don't know what a binary tree is, I would definitely go look at a tutorial. And even at that, you may want to go look at a depth first search tutorial. But the basic idea of it is that you're breaking the tree into halves rather than going by levels, which is what breadth first search uses. We're going to take it by halves of the tree, and then we're just going to break it down. But yeah, thank you.